Math 20s, this video comes out of chapter 2, lesson 2, trig ratios of any angle. Reminder of a couple of things. We learned about the cast rule in our previous lesson, so we'll use that a little bit. This question is a little bit different. The point P, negative 5, 12, lies on the terminal arm of an angle in standard position. Determine the exact trig ratios for sine, cos, and tan of this angle theta. So first thing I need to be able to do is put a point in the right place. So the point negative 5, 12 should be 5 to the left, 12 up, so there's my point. Now when they say it lies on the terminal arm of an angle, it means connect that point to the origin, and so we're talking about an angle that's there. The smartest thing to do here is just to think about the reference angle for a moment, rather than drawing an angle all the way from the usual initial arm. So if I draw a line straight down from there, I have a right angle triangle, which is convenient because I can use Pythagoras' theorem to find that missing side. So even if I don't worry about the negative here, but whether I square it, a square negative or positive 5, I'm going to get 25 plus 144 is 169. If I square root that, I find out that that hypotenuse must equal 13. So now I can just use SOHCAHTOA and say, okay, well, sine of theta must be 12 over 13. Cos of theta must be negative 5 over 13. And tan of theta must be opposite over adjacent, 12 over negative 5. And notice, given that we're in quadrant 2, sine is positive, the other two are negative if you kept that negative 5 involved. As long as you keep track of your cast rule, you wouldn't have had to write that as negative 5. You could have just had a 5 here, but you would have had to understand what's positive, what's negative in that quadrant. Now notice, to do that question, we did not have to find the angle. Nobody asked us to find the angle. They don't care what the angle is. But let's say in part B, they ask us, find a possible measurement for that angle. How big an angle could that be? Well, I want you to think reference angle, cast rule, or at least reference angle, and then what quadrant am I in? We have way more than enough information to do this question because we know what sine equals, we know what cosine equals, we know what tan equals. Truth is, we only need one of those, because if I do inverse sine of 12 over 13, I'll get a reference angle for theta. If I do inverse cos of 5 over 13, notice I intentionally left out the negative here. When I do reference angles, I never use the negative. I just do inverse cos of 5 over 13, gives me the exact same 67.4 degree angle, rounded to nearest tenth. Or had I done inverse tan of 12 over 5, again, no negative involved, I get the same answer. And then I say, well, what quadrant am I trying to put this in? Well, cast rule or not, the question itself right away was in quadrant 2. So I'm saying, well, what does a 67.4 degree angle in quadrant 2 look like? Well, it looks like the initial picture that we drew. If that's 67.4 degrees, then we would have had to rotate 112.6 degrees to get there, meaning that this angle from the initial arm to the terminal arm, starting from the positive x-axis, is 112.6 degrees. And a little rounding aside, you could check this answer quite nicely just by doing sine of 112.6, cos of 112.6, and tan of 112.6. And, you know, because we rounded this to nearest tenth, they'd be slightly off, but you would get these answers, that sine would be about 12 over 13, cos would be the negative 5 over 13, and tan would be negative 12 over 5.